Hi, welcome to this, my fourth tutorial in my series on factorising expressions. Now, in the previous tutorial, tutorial 3, we started to look at factorising quadratic expressions. And if you're not sure what a quadratic expression is, just go back and look at tutorial 3 on factorising. Now, when we factorise any expression, I've always been trying to encourage you to always look for common factors. And in this kind of quadratic expression, we have a common factor x. But what about this one here, x squared minus 9, has no common factor. But what we're going to do in this tutorial is look at expressions like this. But in order to do this, what we need to do is just step backwards for a moment. Let's have a look at expanding two brackets. Brackets of the form, say, a plus b times a minus b. Let's see what we get. Well, in the usual way, if you're expanding this out, what we have is that this is identical to a times a, which is a squared, then a times minus b, which is minus ab, and then b times a, which is plus ba, but we can write that as ab, and then b times minus b, which is minus b squared. And minus ab plus ab comes to 0. So what that leaves us with is just simply a squared minus b squared. Now, whether you multiplied out a plus b with a minus b or a minus b times a plus b, you'd always get this result, a squared minus b squared. I'll leave it up to you just to check it if you like. A minus b times a plus b, you'll get a squared minus b squared. So what does this mean? Well, basically it's saying that if we reverse the process, if we've got a squared minus b squared, then this comes from a plus b multiplied by a minus b, or as I said, a minus b times a plus b. It doesn't matter which way round. And what we've got here is one term consisting of two factors. First factor a plus b, the second factor a minus b. So we factorised a squared minus b squared. So this is a result that I would encourage you to learn, okay? And it is called the difference of two squares. Why is it called the difference of two squares? Well, we've got the difference sign here, the minus sign. It's the difference between a, which is squared, and b, which is squared. The difference between two squares. And it has this pattern structure. So, let's have a look at some examples that have got that particular pattern structure. And here I've given 5 examples. These last two are a little bit more involved, but they share this particular pattern structure. We've got two terms, as you can see in each expression. We've got a minus sign between each of them, and if you look carefully, you'll see that each of them is the square of something. Like in this first example, this is the square of x, giving x squared, and the 9 is the square of 3. So when we compare it to this, we see that the a is the x and b is really 3, 3 squared being 9. Now you might like to pause the video and try these examples if you feel that you'd like some revision, but I do warn you these last two are a little bit more involved. Anyway, let us just work through these. So this first one, very basic one, follows this pattern. This is the square of x, then this is the square of 3, and we've got a different sign between them. So this is going to be identical, according to this pattern structure, as x plus 3 multiplied by x minus 3. Now you could write x minus 3 times x plus 3, it wouldn't matter, you'd get the same result. Now in this example, y squared minus 1. This is the difference of two squares, this is the square of y, and 1 is the square of 1. 1 squared is 1. So the a would correspond to the y and the b would correspond to 1. So we would get that this is identical to y plus 1 times y minus 1, or you could write it the other way round as y minus 1 times y plus 1. I just did that just to show you that you can write it the other way round. In this example, I picked this example just to show you that you can have numbers and letters all mixed together in the same term, but it is still the difference, the minus, between two squares. This is the square of 4x. 4x times 4x gives 16x squared. And this is the square of 5y. 5y times 5y is 25y squared. So we can write this down as 4x minus 5y being multiplied by 4x plus 5y. Now, what about these two? Well, I've chosen these two because they're a little bit more advanced. Now this one, we've got two terms, a different sign, a minus sign between them. Is x to the 4 the square of something? Well, yes it is. It's the square of x squared. X squared times x squared is x to the power 4. And 1, as we saw earlier in this example, is the square of 1. So if we factorize this, this is going to be identical to x squared minus 1 multiplied by x squared plus 1. But this has got something extra in it. We've got two factors now, but it's not what we call fully factorized, because this factor is again the difference of two squares. This is the square of x, and this is the square of 1. So we can factorize this just like we did down here for this one. What we've got is that this can be written then as x minus 1 multiplied by x plus 1. Now we mustn't forget this factor, but this does not factorize, okay? Don't make the mistake of thinking that this is x plus 1 times x plus another 1. It's not. This is just x squared plus 1. It doesn't factorize any further. So we must pop that in there. So now we've got three factors. Look at each of the factors. Ask yourself again, do any of the factors factorize further? Well, this one, it's got a minus sign between it, so a different sign, but this isn't the difference of two squares because you cannot really find something very nice that squares to give x. So this is fully factorized. None of these factors factorize any further. Okay, now the last one. Why have I picked this? Well, at the moment we've got the difference between two terms, but are they the squares of anything? 72 isn't the square of something nice, nor is 2x squared. So it doesn't look like the difference of two squares. But what I've said to you in all my examples on factorizing so far basically has been checked to see whether there is a common factor. Now, in fact, this does have a common factor. There's a common factor of 2 between the two terms. So what we need to do is pull out 2 as that common factor. And so we'd have x squared minus 36. That will give 2x squared minus 72. So we've got two factors now. The 2, first factor, and the x squared minus 36 is my second factor. But if we look carefully now, notice that this second factor is now the difference, the minus sign, between two squares, the square of x and the square of 6. So we can factorize this further. So put an identical sign down, put the 2 in, and we factorize this as x minus 6 times x plus 6. So we've now got three factors. And we should check to see whether each of these factors factorizes further. But this, although there's a minus sign here, is not a difference of two squares. we can't find something that's nice that squares to give x, and we certainly can't find something that's nice that squares to give 6. So this is it. Okay, this is 2x squared minus 72 fully factorized. Well, I hope you've been able to follow this particular idea, and if you spot this pattern now, a squared minus b squared, called the difference to two squares, that you can now start to factorize expressions like this into this format. Okay, well that brings us now to the end of this tutorial on the difference to two squares.